Okay, we're finally ready to start working on graphing these by hand, which is our big goal in this section. So hopefully we have some good ideas of what to expect from the graphs we looked at in the last example. And now we're going to focus on factored polynomials or getting them factored and then graphing from there. Okay, so again, degree is going to be important. It tells us a lot about the shape of our graph. And when you have something already in factored form, you just have to visualize multiplying that out. So what I'm seeing is that the biggest power is going to come from multiplying an x by a negative x by an x. So that's going to give me a negative x cubed, which means my degree is 3, and it also means my global behavior will be like a y equals negative x cubed. So that is flipped upside down. It looks like this, which means as x goes to infinity, y will go to negative infinity, and as x goes to negative infinity, y will go to positive infinity. So we have kind of a reverse thing happening in this one. Okay, the other thing that we can get is the zeros. We can't determine exactly where those local max mins are until we have some calculus. So that'll have to hold off and just be something that we do with technology, and that's why we're just working on rough sketch. But for zeros, remember we imagined setting this equal to 0, which means either factor number 1 equals 0, so x would have to be negative 5, and zeros are points, so I'm going to actually write that out as an x-intercept, negative 5, 0. The second factor would be x equals 3 to make it 0. And again, we've set that equal to 0, so we're forcing that y is 0. I don't know why I just gave that a squiggly bracket. And then the last one, x has to equal 6 to make that equal to 0. So we have our 3 x-intercepts, and really global behavior, x-intercepts, and multiplicity will add to the list. We don't have to worry about that right now. But with those things, we have enough information to get a really nice rough sketch of this. So let's go negative 1, 2, 3, 4, 5, 6, and positive 1, 2, 3, 4, 5, 6. And we don't really care what the vertical scale is. Sometimes I'll see people find their y-intercept and use that to help them. So that's perfectly possible, and then you'd want to kind of know where that goes on your y-axis. But for our purposes right now, we just want a good general idea of the shape. Okay, so this right here is what's going to help me figure out how to get started. Oh, I'm sorry, I'm getting ahead of myself. I didn't draw these. My x-intercepts are at negative 5, 3, and 6. So I need to cross through at those points, but I need to know, where do I start from? Do I start from the bottom of the graph, the top of the graph? And that's where that piece that I just circled helps me. So I know on the far left, as x goes to negative infinity, y goes to positive infinity. So that's telling me that I need to, on the left-hand side, be headed up. And as x goes to positive infinity, that's heading to the right. Y goes to negative infinity. So on the far right, I need to be headed down. So this just gives me a starting point. So that means I'm going to come from the top of the graph, and I'm going to cross through at negative 6. The reason, and again, I'm kind of getting ahead of it because we haven't seen any other powers yet, but the reason I know it's a cross straight through is because it's a first power on that, which makes it behave somewhat like a linear function when you're zoomed in on that intercept. So it's going to cross straight through, and then I know it eventually has to turn around and come back up. So this is total guesswork. I don't know how low it goes. I don't know exactly the x-coordinate of the maximum, although I'll give you a hint. It's usually a third of the way from one of your intercepts, so it probably should happen a little more over here. But that's a lot of calculus knowledge again, so you don't need to memorize that unless you want to be a little more accurate. And again, cross straight through because those powers are all 1. And then I'm going to turn around a little quicker since these are closer together, cross straight through at 6, and head to negative infinity. So a big part of this is just knowing the shapes that polynomials have. They have this smooth and continuous. We know where to start and end, and we know where to cross through the axis. So that's a totally decent rough sketch of this graph. While I'm not picky about how far down you go for that minimum or how far up for the maximum, I will be picky about the smooth part, so don't make any sharp corners for me. Polynomials do not have sharp corners. Mine may be a little bit too rounded, but they definitely don't have sharp corners. Okay, so that's going to be our general strategy. Global behavior and x-intercepts are going to give us pretty much everything we need to know.